In this problem, we will examine the acceleration of a block on an incline. In this case, we will draw a block on an incline at an angle of theta degrees. This is our block. The forces exerted on this block, which we need to examine first. First, we have gravity pointing down. We have the normal force. Let me mark this, mg for gravity. We have the normal force. Notice the normal force is always pointing perpendicular to the surface. Always at 90 degrees to it. In fact, that's what normal means. We also have friction, or we may have friction. Since this block will be sliding down the incline, friction will be pointing back up the incline. We'll mark this as mu n, or simply friction, where mu is the coefficient of friction. We can use either the static coefficient if it is sitting still, or the kinetic coefficient if it is already moving. In order to work out this problem, we need to use Newton's second law. The summation of forces in the y direction and the summation of forces in the x direction. Now, to do this, there's an easy way and a hard way. The hard way would be to find the x and y portions of the normal force and the x and y portions of the friction force. That makes more work than we need to do. The easy way is to take our gravity vector instead and to treat this as level. This now becomes x. This now becomes y. And this angle right here is the same as this angle right here. A little geometry will show you that's true. This angle right here happens to be the complement of this angle. Therefore, this angle is the complement of that angle. Therefore, these two angles are the same. The interested reader can take a closer look. The important point of this is that this right here, this becomes mg cosine theta, and this right here, vector becomes mg sine theta. So, if we want to add up our forces in x and in y, we can say, okay, our forces in y. We have the normal force, and we have the part of gravity that's pushing into the incline. We can write that mu g cosine theta. Now, one thing to notice, the block is not moving off the incline. It's not flying away. It's not flying away that way. The block is not going into the incline. Therefore, in the y direction, the block is not accelerating. That means we can write the summation of forces equals, of course we know, mass times acceleration. This means the acceleration in the y direction must be 0. This is very useful. We'll come back to this in just a moment. Now, forces in the x direction. We have mg sine theta. I'll call that our positive direction, because that's the direction that's going to be accelerating. Blocks slide down inclines. Mg sine theta minus mu n equals mass times acceleration. If there is no friction, our coefficient of friction is simply 0, and we can just forget this whole term. Just forget it exists, because that's a 0. Anything times 0 is 0. So we can ignore it. Now, in order to solve this, we need to take this top equation and solve it for n. So we write n minus mg cosine theta equals 0. If we add mg cosine theta to both sides, then it cancels out here, of course, and we get n equals m, mass, g, acceleration of gravity, cosine of the angle of inclination. Now, if we come back up here, take our equation for Newton's second law in the x direction, we can write mg sine theta minus mu, n. We have n to deal with. N is mg cosine theta, so instead of writing n, we write this. This will make it much easier, actually. Cosine theta equals mass times acceleration. M is our mass, but you know what? It turns out we don't need it. It doesn't matter. It doesn't matter at all. So we could divide both sides by m, divide by m, divide by m, and we get g sine theta minus mu g cosine theta equals a. Now, there is one case we need to watch out for here. If a becomes a negative number here. Now, since we said that going down the incline was positive, going up the incline would be negative. That's just the way we happen to define it. What the upshot of that is, blocks don't travel up inclines unless there's some kind of extra force. Friction is not going to be stronger than the force of gravity. So therefore, if this turns out to be a negative number, what that tells us is that friction is enough to hold it in place or to stop it. If the block is already moving, it will slow down until it stops. So if it's already moving if it's already moving down the incline, it will continue until it slows down and stops. In which case, the block will not move. But in general, this is our solution.